Welcome back for one last video on transformational geometry. And what we want to do is we want to consider figures which are infinite. And for us, we want to think of ones that extend infinitely in one direction. So that is, or one dimension, right? So to the left and to the right, or up and down, but not infinitely in two dimensions. So let's take a look at this a moment. And there are two types of symmetry for these objects, for these figures. Translational symmetry, so moving things to the left and to the right for our examples, or glide reflection symmetry. In this case, what we usually do is we reflect over a horizontal line and then move to the left or to the right to get things to line up again. Okay. So for translational symmetry, observe in each of these cases that if we were to consider one particular point, we could move over a little bit more than that, move over a little bit, and we would put the figure back on top of itself. But I could move a little bit further over to here, right? Lots of different options there. So I can translate to the left and to the right. And what we want to focus on here is that these are extending infinitely, forever and ever, to the left and to the right. I could do the same thing with this, right? I could take one of the S's and I could move it over as much as I desired. So these both have translational symmetry. It is worth noting that we do have other symmetries for these as well. While translational symmetry doesn't apply to the examples that we've already considered, the other symmetries of rotational and reflectional do apply. So I could, in fact, rotate this first one. Let's see here. I could rotate it and end up with the same thing as well. So it does have rotational symmetry, but it does not have reflectional symmetry. Okay. And in this case, let's see here, I don't have any yes, I don't have any lines of reflection, right? If I were to draw a horizontal line and I reflected it, I would end up with a bunch of S's that were backwards. So it's also doesn't have any reflectional symmetries. Again, if I reflected over a vertical line, same thing. The S's would all be backwards. So no reflection symmetry. But it does have rotational symmetry. Right, if I were to rotate about this point here, rotating it would give me the same thing back. I could even rotate here, it would give me the same thing back. So in the middle of an S or between two S's, and I would obtain the same thing back. Now, if your S's were the style that had a small top and a large bottom, then of course we wouldn't have the rotational symmetry. So the particular font that we're using matters here. But also notice that we can choose to, right, we don't have to use letters. And most of the examples that we look at do have letters, but know that you can use, right, designs like this, and you can even use letters that are upside down. So if you wanted to use an L, you could do that, and you could make that L upside down, kind of looking like a 7, although 7s would look maybe more like that. So, but you can use these things to get the idea. And this gives us something more interesting than a rectangle that goes on forever. I mean, is that even really a rectangle? Nah. Anyway, so this is translational symmetry. We can move it left to the right, move it left to right, and we can end up with the same thing that we had. These also have rotational symmetry, but no, these particular examples have rotational symmetry, but do not have any reflective symmetry. reflectional symmetry. All right. So we can also consider glide reflectional symmetry. So that is, we reflect it and then move it a little bit, or we move it a little bit and then reflect it. So for these, usually the line of reflection is the line through the middle. And if you notice carefully here, if we were to reflect this, we would actually end up with B's and Q's. And if we were to move that to the left or right, it wouldn't actually match. So this was a mistake. I didn't know this mistake was here. This is not an example of something that has glide reflectional symmetry. If we wanted to consider something that does have glide reflectional symmetry that's similar to this, we would actually want to use PB. Again, note the particular font you use may change that, but PB is what we're interested in there. If I were to reflect it, right, I would end up with something that looks like BP, and then I would just have to move it over a little bit so that way it lines up back to what it was. But of course, this reflection should occur over the line through the middle of the letters. So that way, all I have to do is move to the left or to the right, and it would line up with the original figure. All right. Let's see here. And then, so glide reflectional symmetry can, in some cases, right, we can have that's simply reflectional symmetry. If there's no glide, that's okay. And that's what what our second example is. If I reflect over this line, then what I end up with is the same thing. So that's where we're talking about a glide reflectional symmetry. We can do that. And we could also move it over to the left and to the right, and it would still be the same thing. So we could say it has reflectional symmetry because I could just reflect over that horizontal line, but it also has glide reflectional symmetry because I could reflect it over that line and move it to the left and right a little bit. And then, of course, both of these, all of them we're looking at here, have translational symmetry, or these two have translational symmetry as well. Okay. Actually, even this guy had translational symmetry. All right. So we would like to investigate those a little bit more, but what we're going to do is we're going to have you complete it through an activity. So there are 5 different symmetries that an infinite wallpaper border could have. So when we're talking about infinite wallpaper borders, we're talking about right, letters being repeated, simple designs being repeated, that sort of a situation there. So we have 5 different symmetries, and you may surmise what they are. I believe you're capable of filling out what these are. And then for these 5, they can be combined in different ways. Although maybe I'll give you a hint because these 2 appear to be the same. I'll start you out by saying that the first 2 should be translations and glide reflections. There are some examples of rotational symmetry. We looked at those here. There are reflections through, well, look above, right? It discusses the reflections. And then we can combine these. So I'll let you fill these in as well as these. The biggest thing is that every wallpaper border, right? Every sequence of letters or every sequence of symbols should be or should have translational symmetry. So they all should have that. And then the remaining 5 appear in different ways. Now, of course, you could consider all possible, or the remaining 4 could all appear in different ways. The entire number of ways that these could be combined is 2 to the 4th, right? 16, but there's only 7 that actually occur. So on a separate piece of paper, see how many different ways you can get these combinations of symmetry. You should be able to find 7. If you have questions about how to approach it, or if you have questions about whether you found the correct things or not, feel free to ask. We can double check and discuss your answers that you find for this activity. All right, and that's it. Yay, that's it for section 25. The rest is just the exercises. There's nothing to hand in, but please make sure that you consider all of these exercises prior to our next exam. So, well, right, I guess not the next exam, but of course the exam over this content, whenever that occurs. So thank you for your time and attention for this incredibly long section. I've enjoyed it so far, and there may actually be a little bit more to discuss, but maybe that will just be an investigation that I give you guys at some point, or just a video. So I'll see you guys again soon in geometry.